In this video, we will learn about measurement of length from NCERT 11th Physics Unit 2. Length is a fundamental quantity and length is used in many physical quantities, say distance, displacement, velocity, acceleration, force, work, and the list is very long. Most often we need to measure length, but the lengths which we measure are of wide range from as small as 10 raised to power minus 5 meter, for which we use screw gauge, to 10 raised to power 3 meter, say, for which we may use a meter scale. But the range of length in physics is very large. We have nucleus as small as 10 raised to power minus 15 meter and universe which is as large as 10 raised to power 30 meter or even beyond. Now we have limitation in measuring lengths. Say with help of screw gauge or spherometer we measure lengths as small as 10 raised to power minus 5 meter, and with meter scale we can measure distance large as a kilometer. But to measure distances which is very small, much smaller than 10 raised to power minus 5 meter or much larger than a kilometer, we use indirect methods. Here we will learn about one such indirect method which is called parallax method. Let us understand what parallax mean. Say our eye is focused to some object and behind this object at large distance is another object. Say the two objects are in line in front of our eye. Now I shift my location to a nearby place. Then the orientation of the two objects change. That is, the line joining our eye to these objects are different now, and there occur a small angle between the two lines joining the object to our eye. This small angle is result of parallax. That is, these lines are almost parallel. Here, for sake of drawing, we have exaggerated it, but these lines are, we will assume, parallel, very close to each other, with the angle theta being very small. The distance between the two positions of our eye is called basis. So we can use some geometry here to solve this situation. Say the original line and this line are parallel to each other, with the third line forming small angle. Hence this angle will also be theta from alternate angle. Hence the separation between the 2 points, let's say D, the base length, let this be R, can be related using right angled triangle theta as D upon R. That is, tan theta is equal to D upon R. Now if the angle is very small, which is the case here, then tan theta will be approximately equal to theta and theta will be equal to D by R. The same result we can obtain for arc of a circle. Say if I assume this to be arc of a circle and these two lengths almost R being the radius of the circle, then the angle between them theta is equal to arc length divided by radius. So when the angle is small, so we can use arc length to find theta, or if I know theta, I can find d or r. So by using two known values, whether it be theta and r or theta and d, we can find the third variable. Say we have a distant object on earth located far away from us, and we have a stationary star in the background. So we can locate this point by drawing a similar line here and then moving our eye to a nearby position. Now the star which is very far away will still appear in the same direction because it is very far away from us, and by our slight movement the direction of the star is not going to change, like in case of north star, because it always appear in north direction. The drawing is little bit exaggerated here for sake of clarity, but the object which is not that far away will form certain angle here with this original direction. So let this angle be theta. Now we can always measure this angle theta and record its value. The distance which we have moved for the two observations be d, this angle will be theta, and obviously theta will be small, say very small, and from the above illustration we have theta equals to d upon r, where r is this length which is almost equal to this length too. So here we know distance d, we know angle theta, hence r can be put as d divided by theta. So by substituting values of d and theta, we will obtain value of r. But remember, theta should be used in radian, because in physics the formulae comply with radian measurement. The reason being that while using arc length as radius times theta, the angle used is in radian. So we will convert the angle measured into radian and use here. Hence this way we can measure distance of a distant object placed on earth, or a satellite, say like moon, or a closer star. So this is a useful indirect method for measuring large distances. Thank you.